searched online for like what we should make. We had a very good in mind, of course, safety collectors, and one of the most popular things which like they said is like was shipmaking, so we decided to go with that. And we made this. This game was inspired by an iPad game, which like made kids like play. So we decided to go with this. And as one said, one of the axis of rotation is due to the racking pinion. So we bought a rack. It had it was like completely built and we sanded the sides to make it a flat surface, and we added 3D printed these rack holders so that it just moves in like on one axis on the x-axis, and the gear is fixed. It just rotates in one place when you rotate the stand. So the rack moves when you rotate it, and the rack was supposed to be connected with like laser cut connectors, but this thing broke. I don't know. So we connected it with wires and it works. I think they're nickel wires and they're pretty strong. So if you rotate it, the rack would move left and right and cause tension in one of the wires, and it would rotate in that direction. And here's the video. It will now explain the second mechanism that we have.
So we've all played a lot of obstacle games, a lot of maze sports, played Labyrinth of the iPhone. But we've always had static obstacles to deal with. And once you deal with static obstacles a few times, those obstacles, it's easier to cross the board. So we thought, why not take it a step forward and have dynamic obstacles? So we use a simple slider crank mechanism in which the motor would rotate one of the gears, and the gear was connected to a crank and a follower. And the follower was in a slit that's installed on the board. And and Gru's arch enemy Vector X was connected to it, so he would be moving around, translating along a similar path. The problem we had here was the motor we got wasn't strong enough to rotate the gears, and we didn't have enough time to go buy another gear, as the estimated time for delivery for another gear was about 2 to 3 weeks. So we just, the motor, sorry. So we just took it out of the mechanism over here to show how it was intended to be used. So Vector X was supposed to be connected to the top of this, and the motor would run this gear and this gear would rotate it. And when the slit was placed in between, this would just translate along one axis. So we have a video which shows exactly how it should be working. And like you can see, vectors will be just translating along one of the axes. And now we'll just show you the final assembly of our presentation. Before that, we had a few problems that we encountered on our way. So as the rack was offset from a certain distance from the wall, we had to make sure that the shaft in the gear was glued to the right point, so that rotating the shaft would actually rotate the gear, which would rotate the rack. So that was something that we fixed. We had to design a lot of small parts because the rack was really small, due to which we ran into a lot of problems. Like Atishya said, the connector brackets, the holes were really small, due to which the laser cut parts weren't precise enough, because of which we ran into a different problem, and thus we had to use wires. The motor, like I just explained, was another problem. We had another problem, which was when the ball would fall through the holes, it would not get returned to the users because we had a closed box. So we modified that by using a ramp below the box, and so the ball would roll down on the sides, as you can see. And now Iswan will show us the final assembly.
So as you can see, this is our final assembly. And then up the base is the two ramp. Above the ramp is the rapid pinion mechanism. We initially designed the bracket, but we found that bracket is very weak, so we just replaced the bracket with the nickel wire, and we attached the nickel wire up to the board, attached to the hook. The hook is ridge attached to the board, and
questions?
What's the goal again? I got lost in the process. I get the goal of what's the goal here?
So we have a maze board and there's a metal ball. So we have to guide the metal ball from one end to the other end.
There's a banana ball.
So I'm sorry, you couldn't see that. So and like the moving, the vector x is supposed to be moving, but because we don't get the motor moving,
Oh, okay.
it's stationary at the moment. But we have to guide the ball through the obstacles, avoid the holes, and reach the final banana ball.
So as you mentioned, there's an iPad version, so similar.
Yeah, but it's not really basic, it's like normal wood.
I suppose there's a mini base
Yeah.
similar
Sure,
to
yeah.
an iPad. What is the advantage of real board game?
It's a more classic game. I would say plus it strains your eye lesser than using an iPad. You can strain your eyes like using an iPad, so it's better to use a physical model. And
And if you run out of battery.
so that's the other one.
Yeah.
Are the obstacles fixed or is there a way to move them?
The obstacles are fixed, but if we had more time, we want to actually install slots. So like if you play the game of life, you see how the houses are attached. So the same way we could actually attach
There
obstacles.
is actually a trick,
And
but the assembly didn't
But
work
due to
out
our
the
due to
motor.
the timing constraints and due to the amount of parts that we could 3D print, like we couldn't actually get that done. So that will be probably something to the future.
And we also have this little plug, so we can just plug in these
We can
poles
cover the holes
to cover the holes
copy that.
to change